Hello. In this video, we're going to talk about sets theory, but well, what is a set? Well, a set is simply a collection of objects, and the objects are called the elements of the set. Some of the sets are so commonly used that they have their own symbols, like, for example, the natural numbers. Yes, when we have the 0, 1, 2, 3, 4, and so on, right? Or the integer numbers where we have, well, then infinite numbers and the -2, -1, 0, 1, 2, and so on, right? So, well, but we can also have sets like, for example, the possible outcomes of tossing a coin, which, let's say the set A is equal to head and tails. That are the possible outcomes of tossing a coin, right? So if we wanted to say that an element belongs to a set, we're going to use this symbol, which represents that something belongs to something else, right? So let's say, for example, 5, it's a natural number, right? So we wanted to say that 5 belongs to the set of natural numbers, so we're going to write 5 belongs to the number of the set, which is the natural numbers, right? There are several ways to describe which objects belong to a set. You can explicitly list the elements of the set, like, for example, let's say the set D with the elements 0, 1, 2, 3, 4, and 5. Here we're writing all the elements of the set, or we can use builder notation where we're going to describe the properties of the set's elements. Okay, so we can write this like, for example, V equals all the x such that, well, x is going to be greater or equal than 0 and less or equal than 5, right? So in this, here we're going to describe that the numbers that belong to this, or the elements that belong to these sets, are the numbers 0, 1, 2, 3, 4, and 5 inclusive. And that's it. Now we're going to see the different operations between sets. We're going to start the union, and we're going to start with the union, and we're going to use Venn diagrams to see what that represents. Okay, so when we talk about the union between two sets, we're talking about that we're going to take into account all the elements that belong to one of the set or the other set, or that belong to both sets. Okay, so the union, we're going to represent it using this symbol, right? Like, for example, A united B, okay, or the union between A and B is going to be equal, or the elements that belong to this are all the elements that belong to A, only A, okay, and all the elements that belong only to B, or the elements that belong to both of them, okay? So in this case, the elements that belong to the union are 4, here we have it, 2, 5, and 3, okay? Now we're going to use 3 sets to see how this works with this, okay? So remember that the union, we're going to represent it with this symbol, so we're going to find out the union of A united B. So A united B, it's going to represent all the elements that belong only to A, or only to B, or both of them, right? So now let's say that we're going to find the union between A and C. So the union between A and C, we're going to erase this one, are going to be all the elements that belong to only A or only C, right? Or both of them, right? Now we're going to see which one it would be the union, which one would it be the union between A united B united C. So in this case, we're going to take into account all the elements that belong only to A or only to B, right? Or the elements that belong to B and C, or A and B, or A and C, or the elements that belong to all of them, A, B, and C, which in this case would be 6. That is what the union represents. Now let's talk about the intersection. The intersection means that we're going to take into account the elements that belong to both of the sets or all the sets that we're going to talk about. Okay, the intersection, we're going to represent it with this sample. So the intersection of A intersected B are going to be the elements that belong to both of them, right? In this case, 2. So now let's see the intersection when we're using 3 sets. So remember, we're going to represent the intersection with this sample. So which one would it be? The intersection of A intersected C. So for that, we're going to take into account, well, these elements, right? The intersection where the part that they share, right? So in this case, would it be 9 and 6? Now let's say that we're going to find the intersection of B intersected C. So in this case, we're going to take into account, well, the elements that belong to B and C, which in this case would be this one, right? The 6 and the 3. Now let's say that we're going to find the intersection between A and B and C. So in this case, will be all the elements that belong to all the 3 sets. So which one is the only element that belong to all of the sets? So it's going to be this little guy that we have here, that is the 6. Okay? But remember that we can also have, like, for example, the intersection of a union with a set. So let's say, for example, that we're going to find A united B, and this one intersection, the intersection of this with C. Okay, so first we have to find what is A united B. So A united B, I'm going to write it here like this bar, we're going to subtract it in green, right? A united B, we're going to subtract it in green. So remember that it's all that belong to A, or all that belong to B, or all that belong to both of them, right? So that is A united B. Now we're going to represent the intersection with C, okay? So what is C? C is all this part, right? So the intersection is going to be only what they share. So what they share is where the both colors are, so we're going to set that it's only this part. Okay, so in this case, the intersection between the union A united B and the intersection with C, so would it be this element, the element 9, the element 6, and the element 3. Got it? Now, the last operation that we're going to talk about is the complement. And to represent the complement, we're going to use a comma like in the top of the letter. So we're going to say something like a complement, this one. And here in this case, what we're going to take into account are all the elements that doesn't belong to the set. Okay, so if they're asking me for the complement of A, well, they're asking me for all the elements that doesn't belong to A. So in this case, well, it's everything that is outside A. Everything that is outside A. Okay, doesn't matter if it is inside or that belong to other set, as long as does not belong to A. So in this case, the elements that belong to the complement of A are 1, 3, and 5. Okay, so we're going to write 1, 3, and 5. And that's it. Now let's see how we work with the with 3 sets. So we're going to again find the complement of A. So again, remember, are all the elements that does not belong to A, right? So everything that is outside A, okay? Everything that is outside A. So in this case, what we're going to have are, well, which elements were we going to have here? The 1, we're going to have here the 8, the 3, the 5, and the 7. Those are the elements that belong to the complement of A because does not belong to A. And that's it. So that's it, guys. Thank you so much for watching. If you have any question, please let me know, and I'm going to try to help you solve it. And see you next time. Bye bye.